Hello, welcome. Today let's try to solve Leetcode problem 1406, still game 3. So if you did a still game like 1, 2, or 4, normally this still game 3 is not so difficult. Yeah. Let's try to understand the problem. So it will still be Alice and Bob. They will take turns with Alice start first. So on each player's turn, that player, for Alice for example, can take 1, 2, or 3 steals from the first remaining steals in the row. The only difference is, it will start to take steals from the left to the right. So for Alice, Alice can take 1 or 2 steals or can take 3 steals. If Alice takes 3 steals, so for Bob, we'll get 7. Yeah, so it means Bob will always win, so we're gonna return a Bob. So if Alice wins, we're gonna return Alice. So if there is a tie, we're gonna return a tie. Let me explain the minimax problem for the dynamic programming a little bit. After that, I will go to the code editor to code it up. Now let me I cannot find it. Yeah, let me try to do some drawings for this problem. I remembered opened a while ago. It suddenly closed, so I have to open it again. Let's try to analyze the Alice and Bob operations. So what Alice do and what Bob do. So from the beginning, we have a array. Inside there are some numbers. So for Alice's turn, this is for Alice. Alice can get some values. For example, Alice can get this kind of values. And what left behind for Bob, Bob can also get some values. So Bob will get some values from here. Yeah. Let me just try to use numbers to explain it. Yeah. So for Bob, for example, Bob will get a final result, maybe 1, 2, 3, 4. Yeah, just example, maybe 2, 3. So what Bob's job? Bob's job is to minimize the value and give a minimum value to Alice. So from here, Bob will give a value 1 to Alice. And from here, 3 and 4, Bob will give a value of 3 to this result of Alice and this DFS of Alice. And from here, Bob will give a value of 2 because Bob will always give the minimum value to Alice. Now, if inside Alice have a value, for example, of 5 or 4 or 3, but finally for the function return, it will be the maximum of 5, this 5 plus 1, and this 4 plus 3. So 4 plus 3, and this is 1, and this will be 3 plus 2. Yeah. So the final result, how many steals Alice get, is the maximum of these 3 values. So it will be maximum of 6, 7, and 5. So we're gonna return a 7. So this is how many steals Alice can get. So Bob's job is always to minimize, and Alice's job is always to maximize. So for the game theory, Alice and Bob are just playing games. Alice just wanted to win Bob. If Alice wanted to win, Alice always wanted to get the maximum, and Alice wanted to make the Bob get the minimum. Yeah. So for Bob, vice versa, it's the same. Bob wanted to get the minimum. So if Bob wanted to give a value to Alice, so it means what left behind to Alice, Bob will always give the minimum. Yeah. But for Alice, if I were to return the final result, I would always return the maximum. Yeah. And we can even go down here to Alice. And after that, we can still go to Bob. Yeah, so Bob is still the minimize, and Alice is still the maximize. But for the final function return, it is from here, the final result, the maximum of these numbers. Yeah. If you understand basically from here for the minimax, normally you can solve this problem. Yeah. Now let me try to finish this problem. So normally I'm gonna use a case with DFS because I'm not sure how, the length of the string. Yeah, the length of the string is a very big number. It is 5 times 10 to the power of 4. So it means I have to use a case, otherwise I cannot pass. Yeah, because if I use a case, basically this is just O(n) time complexity. If I don't use it, will be 2 to the power of this big number. Of course, I cannot pass. So let me try to use the case with DFS. So I'm gonna define a DFS function. So inside, I gonna prepare some values. So I will always start from the beginning. So I'm gonna have an index I, and I'm gonna have Alice as always, because Alice and Bob are playing games. I'm just needed to check which turn is for Alice, which turn is for Bob. So I needed to use Alice. Now I'm gonna have a pass, but for the final function return, it will be the the final function return. It is not DFS directly. I would give an answer to this DFS. Yeah, because I have to check who will win. I'm not just counting the numbers, the values Alice can get. I also need to check Alice will win or Bob will win or there is a tie. Yeah. So inside the DFS, I'm gonna start from 0, and it will be always true because Alice will always start first. Yeah. And there's also 1, 2, 3. It means for the each of the turn, Alice or Bob can always take 1, 2, or 3 numbers. So for this one, I have to check. Yeah. It means inside I need a for loop. Now, let me check the edge cases first. Yeah. So if I equal to the length of still values, it means out of the boundary, I need to give a 0 as my return always if it go out of the boundary. Now I'm going to have a result as my negative infinite if Alice's turn. Otherwise, if Bob's turn, I'll give an infinite. Yeah, because inside of the fields, it can be negative values. So I cannot just give a 0. I have to give a negative, infinite value. And here, I have to give a positive infinite value because I'm going to use a minimax. Now I'm going to loop through. I think I can loop through directly. Now I can loop through the Alice turn. So for I in range, I'm gonna start from 1 to 4. Yeah, because for each turn, for example, Alice can always get 1, 2, or 3 steals. So here, 1, 2, 3. So in Python, this range 4 is not included, so it will be 1, 2, 3 steals. Just means. So yeah, since inside the DFS it is I. So for here, I will use a J as the number of steals. Yeah. Now I'm going to count. Yeah, and also I need to accumulate the steals. It means I also need a variable to accumulate the steals. So I would prepare a total equal to 0. So for my steals, I can accumulate the steals, for example. So if j equals to 1, so my steals will be the steals value with, so I will start with I plus j. So for j equals to 1, actually my first steal it is index 0, but j equal to 1, I equal to 0, so I have to minus 1. Or you can also use for j in range just 3, and you can put just I plus j without -1. Yeah, it always depended on you how to you define the function. So I'm gonna to choose 1, 2, or 3 steals, but inside the steals value, I'm gonna to start with index 0. Yeah, so I plus c minus 1. So this is how many steals I can get. Yeah, this will accumulate the steals. But I think I also need to check the boundary of I plus j minus 1 have to be more than and equal to, if it is more than and equal to length of the steals value, I'm gonna break it. Yeah. So here means if it is out of the boundary. So if I plus j minus 1, so yeah, if it is a y minus 1, because so for here c is always started with 1, 2, or 3, but for the index it is started from 0. So here basically I gonna need to minus 1, and if it is more than and equal to the length of the steals value, so I gonna break the for loop. Otherwise, so the total will accumulate it. Yeah. Now I'm going to check if it is Alice's turn or Bob's turn. So if it is Alice's turn, so I can use if Alice, the result would be the maximum. So for here, I can use put a result inside, because here I prepare a result and here is a for loop. So basically I will compare each of the DFS with my result. Just need to return a maximum value. So inside it's gonna be DFS I plus j. So here I don't need to minus 1 because I used 1 steals, so I should plus 1. If 2 steals, I plus 2. If 3 steals, I plus 3. Just need to shift the index. From beginning, it is 0. If plus 1, it goes to 2. If plus 2, it goes to 3. If I take 3 steals, it goes to minus 9. Yeah, so this means I plus j. And inside, it will be not Alice, because for the next time, it will be Bob's turn. Yeah, basically this is for Alice, but I also need to plus this total value. Yeah, because for Alice's turn, I always need to get the values. Yeah, now if it goes to Bob's turn, for the result, it would be the minimum with the result and the DFS. But for this one, I don't need to plus the total, because for Bob's turn, even how many steals Bob get, it doesn't matter to Alice. So for Alice, just need, yeah, for Alice, for Bob's turn, Bob's job, because our final result is for Alice. So for Bob's turn, how many steals Bob get, it doesn't matter. But what Bob's return to Alice is just this DFS. So just take it out. What's left behind is just return it to Alice. Yeah. And finally, we need a return for this result. Yeah. Before I return anything, let me check if it is right. Let me return an empty string and print out the answer. Just check if this is okay or not. I basically need to calculate these values to check if it is okay. So let's try the examples. So inside, let me check. So for this one, the maximum for Alice is 6. It should be right because Alice can maximum take 6. And let's check the second example. Yeah. So for the second example, Alice can still take 6, but Alice will win. Yeah, it is right. Now let's check the third example. 1, 3, 6. Yeah, let me check the example. Why it is always the same? Oh, it's not. Yeah, it should be okay. And here, let's check the next one. Yeah, so it means it is okay. It is as I expected. It should be 6. Yeah, so for Alice. And this one, it should be 6. Alice will take the maximum. And this one, it also be the same. Yeah, it seems okay. Now let me just return the final result. So for the answers, I needed to, yeah, so this answer is just a number. Yeah, I need to give let me prepare a result. Yeah, hopefully I didn't prepare some global variables. So I will give a time as a result. So if they are equal, yeah, so I gonna return this result. And inside I'm going to tag this answer. Yeah, so if answer times 2 more than sum of steals, sum of the steals, yeah, with the steal value array. If it is more than, it means Alice will win. So result would be equal to Alice. And if answer times 2 less than sum of the steals value, so the result should be equal to the Bob. Yeah. Now let me run it to check if it works. So basically this is the entire function. It is not so difficult if you understand the principles of the minimax. So basically there are two ways. I think this is easy to understand. You're gonna use the max and mini. Or there's a even more similar formula. Just use the sum of the result. You're gonna use the suffix sum to solve the problem. But I still think this is easier to understand. Let me just run it to check if it works. Yeah, as you can see, it works, but this example is just 3 examples. It's not. Let me just submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, although it is not so fast because this is not tabulation, but this is easier to understand, and tabulation is too much harder. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problem like this. See you next time.